Hello world! On this video, we are going to review the 5 S.O.L.I.D principles. These principles can be applied to improve code reusability while maintaining a clean software architecture. S.O.L.I.D principles were originally defined by Robert C. Martin, and they established the base for writing clean object-oriented applications. We're going to look at these 5 principles. First, single responsibility principle. This principle states that you should create classes that handle a particular business logic. Multiple responsibilities should be distributed on new classes. That allows for classes to handle specific logic business. By applying these principles, classes become easier to understand, and other developers participating on your project will benefit from it. As an example, if your application supports reporting, calculation, or database storaging, all of these tasks should be handled by independent classes. Open and close principles. When doing class extension, a class should be open to be extended, but closed to modification. That allows for behavioral changes without modifying the original classes and affecting existing instances. Any new feature to a system should be done by extending existing classes rather than modifying the existing one if required. When classes are too tied together, code reusability is very difficult. You should reduce class dependencies. One of the benefits of this principle is that by adding new features to an application, we do not impact existing code, but rather writing new code by extending existing classes. When we fail to apply this principle, that leads us to rigid applications where classes and modules need to be recompiled each time there is an internal change of one of those classes. Third, the Liskov substitute principle, which was introduced originally by Barbara Liskov, a mathematician who said, if S is a subtype of T, then an instance of type T should be replaceable by an object of type S. This basically means when we have a superclass which gets extended by a subclass, all instances of the superclass type should be able to change its type to match the subclass one without breaking the application. Applying this principle leads to clean code and ensures that all subclasses behave the same way as the superclasses one. In order to apply this principle, we need to make sure that our subclasses methods accept the same amount of input parameters as it does on the superclass one. The internal code of the methods might change the logic, but the return time of the methods should also be the same. Similarly, the internal properties of a derivative class must match the declaration types of its subclasses. Then we have the interface segregation principle. This principle ensures the interfaces on our system are consistent. A client should not be forced to depend on interfaces they do not use. This might sound obvious, but when new requirements are added to a system, it's easy to just add them on existing interfaces. That should not be the case. New methods that we add to an interface should be consistent with the existing interface format. If new requirements add unrelated functionality, we need to create new interface rather than reuse existing one. If we fail to apply this principle, will lead to a system full of dependencies. Our interfaces get polluted, and they get reused by different objects which are handled at different business logic. This should not be our case. Finally, dependency inversion principle. This principle is used for decoupling modules and classes within modules. This allows reusability of code when our high-level modules and our low-level modules become decoupled. This decoupling of modules can be accomplished by coding towards interface abstractions. Higher-level modules should never depend on low-level modules. They should always depend on abstractions. Thanks for watching this video, and hopefully you learned the same amount as I did. I hope to see you in another video on this best practice in software development series.